This video is covering BGP AS synchronization. When an iBGP router receives an update about a destination from an iBGP peer, it tries to verify reachability to that same destination inside its IGP. So it could be RIP, OSPF, or anything. If this iBGP router can't find the destination network in its IGP routing table, it will not advertise that destination to other BGP peers. That is what BGP AS synchronization is. So before we go further, I'm going to point out what we've got in this example in this diagram. This diagram represents three different ASs, ISP1, ISP2, and in between them ISP3. And it's representing the fact that this network 192.213.10/24 is known to ISP1. And ISP1 then is advertising reachability to that destination to RTA over BGP, an external BGP connection. Through ISP3, RTA now, or inside ISP3, RTA now will advertise that same route to its internal BGP peer, RTC. And RTC then will check for AS synchronization before it advertises this route onwards to another AS, ISP2. So it's what this bullet says. When this iBGP router receives an update from an iBGP peer, before it advertises it onward, RTC, in order to satisfy AS synchronization, will check in its IGP routing table to ensure that it's got an IGP route to that destination. And if it does have it, then it will advertise that route onwards to ISP2. Now remember what this means. If RTC does advertise this route, then that means that anyone connected to ISP2 down below here will be able to send traffic destined for this network to ISP2. And when it arrives in ISP2, because ISP2 received this network route from RTC, it will send that traffic to RTC. And ultimately, that traffic should work its way through this ISP3 AS over to the edge at RTA, and that traffic will be sent then onwards to ISP1. Because remember, ISP1 advertised that network to RTA, so RTA thinks that that's where those destination packets should be sent, right? This turns ISP3 into a transit AS for this network. And that's precisely why we have BGP, so that we can get this traffic moving from AS to AS all across the internet. So that's AS synchronization. So the obvious question is why? Why is this synchronization necessary? Well, if the route is not reachable through an IGP running inside ISP3, right, this AS, then non-BGP routers like RTB, RTD will not be able to route any traffic passing through the AS towards the destination. So remember, now maybe this diagram wasn't clear, but this dotted line here is the iBGP peering. There's no link there. So in order for the packets coming from ISP2 or customers of ISP2 for this network to come into RTC, in order for those packets to go through this AS and ISP3, it will have to follow these links to RTB, RTD, RTA, and then onwards out to ISP1. So the rationale is this: as my packets come in for this destination at RTC, then RTC must pass it to the next hop, not directly necessarily to its iBGP partner, but next hop of RTB. Well, if RTB doesn't have a route to this destination, then it's going to drop the packet. So RTC says it's pointless to advertise these destinations to the external peers if traffic pulled through this AS is going to be dropped by some non-BGP internal router along the way. On the other hand, if we have this route in the IGP, then RTC assumes then that all the rest of the internal routers also have that route, and it will be routed properly, not dropped, to ultimately RTA at the edge and RTA will then forward it on to the destination. Otherwise, then the router will treat the route as not being synchronized with the IGP, and RTC will not advertise it onwards, because there's no point drawing that traffic if once it arrives, that traffic arrives, it'll be dropped internally. So the BGP synchronization rule states that a BGP router, so in this case RTC, should not advertise to external neighbors, ISP2 in this case, any destinations learned from IBGP neighbors, so this network now from RTA, unless those destinations are also known via an IGP, whatever IGP is running inside ISP3 here. So this slide then goes on to explain what I basically said. That consider the traffic from ISP2 now. If I did advertise this, consider traffic from ISP2 bound for this network entering RTC. This traffic would be routed to RTB on its way to RTA. However, such packets entering RTB will have a destination IP in this network. So if RTB does not have a route for that network, that destination, then these packets will be dropped at RTB. It would not be forwarded on. If a BGP router does have a route to the destination via an IGP, it's assumed that that route is also being propagated inside the whole AS. So in other words, to both RTB and RTD. And therefore, internal reachability and delivery will be guaranteed. Now, that now suggests that these networks being passed into our AS must be known by every router in between. Meaning, we're injecting full BGP routes inside this AS. So that's going to be very costly. Everyone's going to have enough memory and processing power and even link capability to have these passed to them and stored. So that's a major overhead on our internal routers. And typically, our internal routers are not going to be equipped to handle this many routes. But carrying all these external routes is not always necessary. So inside Cisco IOS, there's an optional command called no-sync. And this command enables BGP to override this synchronization rule. And this will allow the router to advertise routes learned via the IBGP, irrespective of whether or not it's inside our IGP. So, obvious question is, well, how is this possible? How is this safe given what we just discussed? Well, in practice, there are two situations where synchronization doesn't need to be there. It can be safely turned off at the border. And by the way, this is the default setting on iOS 2.2.8t or later. So the two situations are this. When all my transit routers inside the AS are running fully meshed IBGP, meaning that these routers that are in the transit path through the AS are running BGP. Remember, we had to have the synchronization before because RTB and D were not running BGP. Well, if they are, then internal reachability is guaranteed because a route that's learned via eBGP at any one of the borders will automatically be passed on via IBGP. Remember our split horizon talk? It is safe to do this. So therefore, we have full route knowledge and full reachability. Now, this does force these two routers to run BGP, but as long as that is the case, then we don't have a problem. The second possibility is when our AS is not a transit AS. So if that's not the case, then we don't really care because the whole problem was having their transit traffic not be routed properly through the AS. But if we have no transit traffic, because our AS is not a transit AS, we don't have to worry about this.